We are in AP Calculus BC. We're on worksheet 2-5. Today's date is Tuesday, March 10th, a little bit late. We're finding the derivative. There's a formula. You don't need to memorize it. We're just doing parametric form. All right, so first we're finding x. X is equal to this thing times cosine. So it's going to be cosine of 2 theta times cosine of theta. And then I'm going to leave some room, or maybe I can do it off to the right. And then I'm going to do, what is y? Y is the same thing. It's cosine of 2 theta, but instead of multiplying by cosine of theta, I'm multiplying by sine. You can write slightly easier. Sine of theta. That's the only difference between x and y. One is with cosine, one is with sine. Now we're going to take the derivative with respect to theta. I guess, instead of t. Although these are kind of changed to t's. I wonder what the formal definition of what's happening here is. Question, Chris?
Sorry, you have tape?
What type of tape? Blue tape?
Clear tape?
Clear tape is over there, I think. So let's find dx d theta. And that is equal to, okay, it's going to be, this is our 1, this is our 2. So 1d2 plus 2d1. I'll write it down. 1d2 plus, I'll do the plus over here, plus 2d1. All right, so 1 is cosine of theta. Oh, cosine of 2 theta. And I multiply that by d2. The derivative of cosine is negative sine of theta. Okay, then I need to add, and then, by the way, I should spread these out so that they look better. That's plus, and that's my d1, d2 is right there. My 2d1, well, 2 is going to be cosine of theta. Cosine of theta. And then d1, be careful of dinner. This one has it. It's 1, so yeah, so d1, the derivative of cosine is negative, so this is times negative sine of the same inner 2 theta, but then take the derivative of the inner, and you have to multiply by 2. So that is d1 right here. All right, and then you have to kind of do the same thing for y. You have to find dy d theta. dy d theta. The derivative of this, again, is going to be 1 d2 plus 2 d1. All right, so 1 is cosine of 2 theta. The derivative of 2 is cosine of theta. Plus 2. Chris, are you doing the homework with us? Because you said you haven't been doing homework, and it looks like you're not doing the homework right now. So 2 is sine of theta. Times the derivative of 1. Again, it's going to be the same thing because the derivative of 1 is still the derivative of the other one. So it's negative sine of 2 theta times 2. All right, we have all the pieces. We need to put them together. How do I put them together? To find dy dx, I could copy paste this. I think I'm going to write it out just kind of quickly here. That's going to be our yellow function first. So it's going to be this cosine of 2 theta cosine of theta minus, because there's a minus sign here, minus 2 sine of theta sine of 2 theta. And it doesn't matter the order. I could have done sine of 2 theta there and sine of theta there. It's the multiplicative property of association, no, of communication, of, I don't know, the commutative property of, I don't know what that property is called. Man, I'm really bad. I should know those. Anyway, that's going to be divided by the blue function. The blue function is up there. It's going to be negative cosine of 2 theta times sine of theta. And that's going to be minus 2. It's going to be cosine of theta instead now, times sine of 2 theta yet again. And there we have our final answer, and it looks gross, and it is gross, but there it is. Final answer, box it. And again, the question always is, well, Mr. Sindel, can't you simplify that? And I don't know how to simplify that. If you do, go for it, but I think for the majority of these, they're going to be gross like that. We get out of here at 52, so I got 3 more minutes. Let's see how far we can get. Okay, thank you for the vote of confidence. So this is going to be x is equal to 1 plus cosine of theta, and that's all going to be multiplied by cosine of theta. The big mistake that's made in number 2 is not putting these parentheses here. You need to put those parentheses because it is the entire quantity of r times cosine of theta. It's not just cosine theta times cosine theta. You need the entire set of parentheses. And then, of course, I'll skip some lines so we can take the derivative. And then y is equal to, again, that 1 plus cosine of theta. All of that times, not cosine anymore, but now sine of theta. All right, time to take the derivative. So the derivative of x with respect to theta now, d theta, is equal to, okay, it's going to be 1 and 2 there, so it's going to be 1 d2. I think she's doing old homework, right? Okay, 1 d2, so 1 is 1 plus cosine of theta. That's 1. And then I multiply by the derivative of 2, that's going to be negative sine of theta. So that was 1 d2, and I'm going to add plus 2 d1. 2 is cosine of theta, and then d1, the derivative of this thing is, well, the 1 is a constant, it goes away. The derivative of cosine is negative sine of theta. And then I do the same thing with yellow. I'm doing 1d2 plus 2d1, so I say dy dt, and this is annoying me. Can I scoot this over a little bit? I'm going to scooch this over just so it's not overflowing into the other box. Scooch this over. How do I want to do this? I'll just be careful and only scooch over this derivative. Scooch, scooch, scooch. All right. Now I have the proper amount of room for my dy dt. My dy dt is equal to 1 d2. So 1 is 1 plus cosine of theta. 1 d2, and then derivative of 2 is just cosine of theta. It's, again, the derivative of just that sine. Plus 2 d1. So 2 is sine of theta. Sine of theta. Times the derivative of that thing, and it's going to be the same thing as it was before. It's negative sine of theta. And then I piece those together. I know that we technically have 30 seconds left, but the bell doesn't ring for another minute and a half. Our dy dx is equal to, and I'm writing the yellow first, the dy dt first. And I could distribute the cosine. I think I'm just going to, yeah, sure. Let's simplify as much as possible. This is going to be cosine of theta plus cosine squared of theta minus sine squared of theta. That's as far as I can simplify it. And that was the numerator. The denominator, what does he look like? Well, I have a negative sine of theta, distributing this sine of theta into the 1, and now distributing it into the cosine minus. I'm going to do sine theta, sine of theta times cosine of theta. And now I'm going to copy down all this stuff, and that's going to be, oh, minus another sine theta, cosine theta. So this is, I have 2 of those sine thetas, cosine thetas, so I'm really going to write here minus 2 of those. So come over here and say minus 2 of those, and final answer, box it. Hey, we got through all of it before the bell rang, and now the bell, where is it, where is it, where is it? There it is.
I'm now recording at my house, so I have to be quiet. Riley just went to bed. Again, we're first going to solve for x. So x is going to be equal to 2 sine, and I should zoom in here so my handwriting looks nice when I zoom back up. So sine of 2 theta, that's going to be multiplied by cosine of theta. Leave some room. Y is going to be equal to, again, that 2 sine of 2 theta times sine of theta. And let's take the derivative of each of them with respect to t. So dx dt, that's not how you write dx dt, Mr. Sindel. Dx dt, that's equal to, okay, so I'm thinking of this as 1, this is 2, so 1 is 2 sine of 2 theta. D2 is times negative sine of theta plus 2, which is cosine theta, d1. So the derivative of this, so I have times 2 cosine of 2 theta, and then the derivative of 2 theta is 2, so times 2. Alright, and very similarly, we're going to do dy dt. This is going to be, again, 1 is 2 sine of 2 theta times, so d2 is going to be cosine of theta plus 2d1, so 2 is sine of theta, and then d1 is going to be the same thing that we had up here in blue, which is going to be 2 cosine of 2 theta times 2. Yeah, don't forget our dinner. And then finally we need to write down our final answer. Well, I guess it's not really our final answer. I can kind of plug in values now. I can plug in pi over 3. So I can say, I can actually do that work underneath here. Sorry about that. I can do this because I have technology. What is dx dt when, and this is the evaluation bar, when theta is equal to, what did it tell us? Pi over 3. Pi over 3. That's equal to what? So I'm plugging in pi over 3 in here. So sine of 2 pi over 3. Again, 2 pi over 3 and pi over 3. Let me draw out where those are on the side over here. So pi over 3 is right here. That's pi over 3. And 2 pi over 3 is right here. 2 pi over 3. So if I'm talking about sine of 2 pi over 3, that's the y-coordinate of this point. So the y-coordinate of that point should be the square root of 3 over 2. So I still have the 2 there. 2 square root of 3 over 2. The 2's will obviously cancel out, but let me just keep writing. Times, okay, sine of pi over 3 now. Sine of pi over 3 is going to be the same thing. It's going to be square root of 3 over 2. So negative square root of 3 over 2 plus, okay, cosine of pi over 3. So again, pi over 3, cosine is the x-coordinate. How far did I go to the right? I went a half. So plus 1/2 times, really this is going to be 4 times something because I have a 2 and a 2 here, so that's going to be 4 times, okay, cosine of 2 theta. So cosine of 2 pi over 3. 2 pi over 3 is right here, and that's going to be cosine, so it's x. X is negative a half here, so this is going to be times negative 1/2. I can make that look a little bit nicer, 1/2. So that is all of the stuff in blue. And can I simplify that a little bit? Again, I'm going to have to keep shifting this down and down and down until I have the final answer. I think I only need one more line. Finally, the 2's will cancel out, so I'm going to change to a different color here. 2's are going to cancel out, so I have square root of 3 times the square root of 3. These two, when I multiply them, I'll get just normal 3. So this is going to be negative 3 halves. That was all of that. And I'm going to do plus, well, if I do 2 times 2, that's 4. So 4 in the denominator, 4 in the numerator, that's going to be 1. This is all going to be negative 1. And then when I get my final answer for my dx dt, when I plug in pi over 3, adding these, this is negative 1.5, and this is negative 1, so the answer is negative 2.5. 2.5. And if you don't like decimals, you can think of this as negative 5 halves. So we have to do the same work down here. Luckily, this is kind of repeating myself now. So 2 sine of 2 theta. So 2 theta right here, or sine of 2 theta, that's sine of 2 pi over 3. 2 pi over 3 again is up here, and sine is going to be square root of 3 over 2. So I have, I'll write this down, dy dt, when I plug in theta is equal to pi over 3, it's going to be equal to 2 square root of 3 over 2. That was this part, times cosine of theta. Cosine of theta is going to be cosine of pi over 3, and cosine of pi over 3 is 1/2, so times 1/2, plus sine of pi over 3 is square root of 3 over 2, and then this is going to be times, again, 2 times 2, that's a times here, not a multiply, or not a minus. 4 times, what is cosine of 2 pi over 3? Cosine of 2 pi over 3 is negative 1/2. So come and say this is times negative 1/2. Alright, simplifying this, the 2's cancel each other out, and I'm left with square root of 3 over 2, so this is equal to the square root of 3 over 2, and then plus all of this thing. So notice that I have 2 and 2 in the denominator, so I have 4 in the denominator and 4 in the numerator, so that's going to, all of this turns into -1. And then that -1 times square root of 3 is minus square root of 3. And I guess I could simplify a little bit. I could factor out the square root of 3 if I wanted to. What I could do is I could get like denominators here. To get like denominators, I would multiply this by 2 over 2. And I would get, so this is now 2 square root of 3, right? So I have normally the square root of 3 over here minus the 2 square root of 3. So minus 2 square root of 3. That's all divided by 2. And I think I'm going to use this fractional notation because I'm probably going to keep it, change or flip it to simplify as much as possible. So finally we can go and say, okay, what is dy dx, the thing I was eventually trying to find. I have my dy when I plugged in, and I have my dx when I plugged in, so let's do the top. The top was the dy, the square root of 3 minus 2 square root of 3, all of that divided by 2. All of that divided by 2. And I guess I should make that yellow because that was our y. Now all of that is going to be divided by the thing that I started with blue, so -5/2. All this divided by -5/2. And this is eventually going to turn into, keep it, change it, flip it. So I'm going to rewrite, let me zoom in here so I have better handwriting. Let me rewrite the yellow just verbatim, right? So it's still the square root of 3 minus 2 square root of 3 all over 2. So I kept it, I changed it, and now I'm going to flip it. It used to be 5/2 or -5/2. Now it's positive 2/5. Sorry, still negative 2/5. And we can see if some things are going to cancel out, namely the 2's are going to cancel out, and this negative is going to be distributed into both of these terms here and here. So my final answer, I know it took a while, my dy dx, I guess I should be saying the evaluation bar at theta is equal to pi over 2. When I plug that in, I get, I'm going to do 2 square root of 3, that's positive now, so 2 square root of 3 minus the square root of 3, all of that divided by 5. Whew. That was a lot of math. Let's try another one. So here we have another function, so let's first find our x, and we'll continue on with x until we eventually touch y. So I don't want to have to keep moving things down like last time. X is equal to that 3 plus 8 sine of theta, and I don't know why I'm not zoomed in enough. There it is. Sine of theta. And then that's all, this entire quantity is going to be r, right? And that entire quantity r is going to be multiplied by cosine of theta. Alright, so let's find the derivative. Let's find our dx dt. And then we'll plug in some things. So the derivative, again, this is my 1, this is my 2, so it's 1d2. So 3 plus 8 sine of theta, that's my 1. And it's going to be multiplied by the derivative of 2, so it's going to be negative sine of theta, plus 2d1. So 2 is cosine of theta, times the derivative of 1. So the derivative of 3 is a constant, so it's 0. The derivative of 8 sine of theta is 8 cosine of theta. So let me say times 8 cosine of theta. All right, and I'm not going to simplify yet. I'm just going to go ahead and plug in. So plugging in dx dt. This is the only way that I know of in notation to say, hey, I'm plugging in pi over 6. You can either just write pi over 6, and that's probably the fastest way of doing it because there's only one variable to plug in for. I was being overly cautious by saying theta is pi over 3, theta is pi over 3. There's only one variable, so it's pi over 6 in this case. So when I plug in pi over 6, what happens? We should first talk about where is pi over 6. So if I do some scratch work, pi over 6 is right here. That's pi over 6, which means sine of pi over 6 is 1/2, and cosine of pi over 6 is square root of 3 over 2. I'm not going to write that down. I think we have our unit circle down pretty well. And if not, you're watching the video, right? So this is going to be 3 plus 8. Okay, what is sine of pi over 6? I just said it's 1/2, so times 1/2. And this is all going to be multiplied by, again, sine of theta I just said is 1/2, so times negative 1/2. Plus, okay, what's cosine of theta? Cosine is the x, so that's the square root of 3 over 2. Square root of 3 over 2 times 8, and then cosine of theta again is the square root of 3 over 2. And I can say those two are being multiplied. Alright, let's simplify a little bit. So what can I do here? Well, 8 times 1/2 is 4, and then 4 plus 3 is 7, and then 7 times negative 1/2 is negative 7/2. So this is equal to negative 7/2. That was all of this. And then over here, I have a 2 and a 2 in the denominator, which is 4 in the denominator, and an 8 in the numerator. So those are all going to kind of cross-cancel, and I'm just left with a 2 on the top. So I'm going to temporarily write a 2. I'll erase it in a sec. So plus 2. Why am I going to erase that? Well, because square root of 3 times the square root of 3 is 3. So 3 times 2 is 6. So I come back here and say plus 6. And then, of course, I need common denominators, so I'm going to multiply this 6 by 2 over 2. 6 times 2 is 12. 12 minus 7 is 5. And the final answer here is 5/2. 5/2. That looks eerily familiar. I got negative 5/2 over here. Alright, that was the blue. That was finding x. Let's do it with y now. So just y without any derivative is that 3 plus 8 sine of theta. That was the original r, right? So all of this quantity is r, and I'm going to multiply that by sine this time, sine of theta. Alright, then we're going to plug in some things. Oh, sorry, we're going to take the derivative first, right? dy dt. So again, this is my 1, this is my 2, 1d2. So 1 is 3 plus 8 sine of theta. That's a bad theta, better theta. 1, and then d2. I should do square brackets here. 1 d2. So the derivative of sine is cosine of theta. Then plus 2d1. So 2 is sine of theta, and times d1. So the derivative of 1 is the same thing that it was up above. So it's going to be this 8 cosine of theta because, yeah, the derivative of 3 goes away. It's a constant, and then 8 times, yeah, cosine of theta. 8 cosine of theta. Cool. So we have our derivative. Now we're going to plug in pi over 6 again. So what is dy dt when I plug in pi over 6? And then this is going to be equal to, I have 3 plus 8 times, okay, what is sine of pi over 6? That's going to be 1/2. And then all of this thing is going to be multiplied by cosine of theta, cosine of pi over 6, which is the square root of 3 over 2. Plus, okay, sine of theta, we already said was 1/2, times 8, and then cosine of pi over 6 is, again, square root of 3 over 2. Okay, I need to start simplifying this thing. Let's do some mental math. 8 times 1/2 is 4. 4 plus 3 is 7. So this entire quantity is 7. And that means if I just squish on that 7, it's going to be 7 square root of 3 over 2. So down here I'm going to say this is equal to 7 square root of 3 divided by 2. What about the right-hand piece of our expression? We have 1/2 and 1/2. These 2's in the denominator multiplied to 4. And then 8 divided by 4 is 2. So I have 2 square root of 3. Oops. So this is going to be plus 2 square root of 3. Notice that we don't have like denominators, so I'm going to multiply the top and bottom by 2. So times 2 times 2. And when I do that, I get, this is going to be 4 square root of 3 now, right? So 4 square root of 3's and 7 more square root of 3's. I have a total of 11 of those square root of 3's. 11 square root of 3, all of that divided by 2. Alright, so we have 2 pieces now. We have the dy dt and the dx dt when we plugged in pi over 6. Let's find out what happens when we find dy dx when we plug in pi over 6. that is going to be equal to a fraction where I do the derivative of the y on the top, so this is going to be 11 squared of 3 over 2, and the derivative of x we figured out was 5 halves. 5 halves. Alright, let's keep it, change it, flip it. So I still have to keep it the 11 square root of 3 divided by 2, change it from division into multiplication, and flip it, take the reciprocal of 5 halves is 2 fifths. And we can see that some things cancel out nicely, so the 2's are gone, and wow, this is very, very similar to our last problem, wasn't it? Where the 2's canceled out, and I'm left with kind of a radical in the numerator, and then I keep the denominator from the right piece. So this is 11 square root of 3 divided by 5. And there's our final answer. Box it. Did we box our last answer? We did. All right. Cool. So that concludes AP Calculus BC Worksheet 2-5.